Hello everyone. In this video I'm going to explain how sine of sum of two angles equals sine A cos B plus cos A sine B. Similarly, what is the derivation, or how do we expand cos A plus B in terms of sine A sine B cos A cos B, and also tan of sum of two angles. So coming to sine of A plus B, the proof is, for example, consider the triangle, a right angle triangle ORQ, and and 90 degrees at angle Q. Now we have two angles. The angle ROQ is angle A plus B, and if you draw a line for angle A like OZ, so angle ZOT forms angle A, then the angle formed by two lines R O and ZO is angle B. So sine of A plus B, if you consider right angle triangle ROQ, sine of A plus B is opposite side by hypotenuse, which is RQ by OR. For simplicity, let us consider our hypotenuse is 1. In a later pages, I will explain if it is not 1, how do we come to the same formula. So consider this right angle triangle. O is the center of a circle and radius of circle as 1. Now sine of A plus B is RQ by OR. So now sine of A plus B is RQ because OR, which is our hypotenuse, is 1. RQ can be is the sum of RS and SQ, and now we'll try to mention RS and SQ in terms of sines and cosines of individual angles A and B. So now draw a perpendicular line starting from point R onto line OZ. So angle at Z, RZO, which is a right angle triangle, angle at Z is 90 degrees. Now from Z, draw a perpendicular line onto line RQ. So it is intersecting line RQ at point S. So now the angle A, which is at O in the triangle ZOT, if you consider angle A in that triangle, if it is angle A, then from the diagram you can see where 90 minus A is, because in sum of three angles of a right angle triangle, or in general triangle, is 180 degrees. So it is 90 minus A. Then angle between R and where RQ is intersecting OZ, though it's not mentioned by any alphabet there, you'll see a dot on the line RQ. Where is it intersecting OZ? So R, the point where it is intersecting OZ, and Z, the angle there is 90 minus A. Then it's easy to calculate the angle formed at R is A. Now RSZ is another right angle triangle, so that's the reason angle at R is A, because you can see the arrow at the point where OZ is intersecting RQ. There is an arrow which says it is 90 minus A. So, and angle at ZSQ, the angle at S is 90. So angle at SZO will be what? It will be A. So that's the reason it's pointed by another arrow A. But again we know angle RZO as 90 degrees. So if angle SZO is A, then angle at RZS will be 90 minus A. Then the angle at R is A. So now let us define RS and SQ in such a way so that RQ, which is our sine A plus B, we have RS and RQ in the terms of sine A is cos A, sine B is cos B. So Sine B equals to, if you see sine B, which is in the right angle triangle R O Z, which is a right angle triangle, sine B equal to R Z by hypotenuse OR, which is 1 for our simplicity. So sine B is equal to RZ. Similarly, cos B, the adjacent side is OZ, and divided by hypotenuse, which is equal to OZ. Similarly, now consider another right angle triangle uh, formed by ZOT. So there is angle A at O. So sine A is equal to opposite side ZT by hypotenuse, which is OZ. Again, similarly, cos A equal to adjacent side, which is RS by RZ. Now, where did we get RS? If you look into the top right of the diagram, there is an angle A at point R. So RSZ is another right angle triangle at right angle at point S. So cos A is obviously adjacent side, which is RS by hypotenuse, which is RZ. Now sin A equal to ZT by OZ, opposite by hypotenuse OZ. So ZT equal to, which is nothing but a parallel line to SQ, so equal to OZ sin A. So SQ is equal to OZ sin A, but OZ we derived before saying cos B equal to OZ. So therefore SQ equal to cos B sin A. Similarly, cos A is defined as RS by RZ. Therefore RS is RZ cos A, but again we derived RZ as sin B. So therefore RS is called sin B cos A. Now sin A plus B, which is nothing but RQ, is sum of two lines RS plus SQ. So if we put RS and SQ together now, it's a summation of RS and SQ. It's nothing but sin B cos A plus cos B sin A. So rearranging the terms, sin A plus B is sin A cos B plus cos A sin B. So the one main point is, here we constructed three right angle triangles. So actually, to start with, we have only one right angle, which is ROQ, and angle at O is A plus B. Then to define sin A plus B, which is opposite side RQ, we constructed two more right angle triangles, which is RSZ and ZOT, and we defined RS and SQ in terms of sines and cosines. So now if we go to the generic formula, where a generic way of deriving it, where hypotenuse is not 1 but a radius of value r, some arbitrary value r, then it will be similar kind of diagram, but instead of 1 we will have a radius r. So in that case, sin A plus B will be RQ, opposite side, by radius is r, which is not 1 now. So of course it can be 1, but it's arbitrary number now, r. So RQ is r sin A plus B. So similar to the previous page, now sin B is we are calculating sin B from right angle triangle RZO, with sin B is opposite side, which is RZ, by hypotenuse is r now. So RZ is equal to r sin B. Now cos B is adjacent side, which is OZ, by r is a hypotenuse. So OZ is equal to r cos B. Now sin A is opposite side ZT. This is from right angle triangle ZTO. Sin A equal to opposite side ZT by hypotenuse, which is OZ. So ZT is equal to OZ sin A, right? But we derived a step before that OZ is r cos B. So therefore ZT is r cos B sin A. So ZT is nothing but it's a parallel line to SQ of equal length. So SQ is equal to r cos B sin A. Now cos A, for cos A you need to consider top right triangle, which is RSZ. I am saying RSZ is a right angle triangle, means the middle letter S, that's where there is a right angle 90 degrees. Now cos A is adjacent side rs by hypotenuse rz. So rs is rz cos a. But again, before we proved, like, look at the arrow from where rz is defined. Is rz is nothing but r sin b cos a. rz is nothing but r sin b, therefore rs is r sin b cos a. So now rq for sin a plus b, rq is the opposite side. rq is sum of two lines rs plus sq. So rq, which is nothing but r sin a plus b, equal to rs, and sq, which is nothing but r sin b cos a or cos b sin a. So we are adding those two lines. Therefore, cancelling r on both sides, we have sin a plus b is equal to sin a cos b plus cos a sin b. In the diagram point of view, you can see rs is nothing but r cos a sin b, and sq is nothing but r sin a cos b, and whole rq length is nothing but r sin a plus b. If r is equal to 1, then the simplified derivation which we discussed before comes into picture. Hope this video helps you in understanding how sin a plus b is sin a cos b plus cos a sin b. Thank you. In next video, I'm going to describe how cos a plus b is cos a cos b minus sin a sin b. Thanks.